Okay, now we take another exercise, and in this exercise our limit is the limit is x approaches to 0, and it is 1 by x minus go on divided by e raised to the power x minus 1. Okay, now since it is 1 over 0 means infinity, and minus 1 over means it is infinity minus infinity form. Okay, so this means that we will apply the L'Hopital rule. So before applying the L'Hopital rule, we will first simplify it. Limit x approaches to 0, x into e raised to the power x minus 1, and it is e raised to the power x minus 1 and minus x, and it is 0 divided by 0 form. Since it is 0 divided by 0 form, so now apply the L'Hopital rule. So what is the L'Hopital rule? X approaches to 0, it is the derivative of, we take the derivative of nominators and denominator terms. The derivative of numerator e raised to the power x minus 1 is e raised to the power x minus 1 divided by x and e raised to the power x, and plus e raised to the power x minus 1. So if we put the yes, it is again 0 divided by 0 form. It is again 0 divided by 0 form. Okay, so this means that we will again take the derivative applying the L'Hopital rule. Limit x approaches to 0, the derivative of e raised to the power x minus 1 is x into what it was, x into e raised to the power x. Okay, so now again take derivative e raised to the power x, and the derivative of x into it will be x e raised to the power x plus ex plus this. Now I think this is not 0 divided by 0 form. So if we apply the limit, after applying the limit, it will be e raised to the power 0 and divided by 0 and e raised to the power 0 plus e raised to the power 0 plus e raised to the power 0. So this will be equal to 1 divided by it will be 1 plus 1 plus 0, which is equal to 1 divided by 2. So take a short look at this question. Move to the next question. The next question is, it is limit x approaches to 0 and it is a divided by x minus cot x by a. And suppose if we put the limit, direct limit, then a divided by x, which is infinity, means this is infinity minus infinity form. So it means we will apply the L'Hopital rule. Before applying the L'Hopital rule, we first simplify it, and we can write cot x by 2 a divided by x minus cot x by a is mean cos x by a divided by sin x by a. So now take the LCM. Limit x approaches to 0. The LCM is x and sin x by a, which is equal to a into sin x by a, and minus x cos x by a. Okay, so now if we check, now it is again because sin 0 is 0 and x into cot, so a 0, it is again 0 but 0 form. Since it is 0 divided by 0 form, so we apply the L'Hopital rule. According to the L'Hopital rule, we take the derivative of the numerator and denominator terms. Limit x approaches to 0 a sin x by a, which is a cos x by a, and the derivative of x by a is 1 over a. Okay, so yeah, and minus the derivative of x cos, it is cos x by a, and the derivative of minus plus x by a and sin x by a. Okay, and now the derivative of x sin, it will be x by a cos x by a. Okay, and plus sine x by a. Yeah, cos by x, it is, yeah, it is, cos x by a minus minus plus, and this a is cancelled out with this. Cos x by a is cancelled out minus cos x by a, and now this is equal to limit x approaches to 0, which is x by a sine x by a divided by x by a cos x by a plus sine x by a, and this is equal to limit x approaches to 0 x by a sine x by a, because it is again 0 divided by 0 form, so this means that we will apply the L'Hopital rule. So it will be x by a means 1 by a, and sine x by a plus x by a multiplied by 1 by a and cos x by a divided by its derivative is 1 by a and cos x by a minus x by a 1 by a, and cos x by a is sin x by a plus 1 over a. Derivative of sin x by a is cos x by a. Okay, now it will be equal to now it is not 0 divided by 0 form. Apply the direct limit. It will be x by a, in the numerator we get 0 plus 0 divided by, it will be 1 by a minus 0 and plus 1 by a. So this will be 0 divided by 2 by a, which is equal to 0. Let's take a short look of this question.